Hey everybody, today we'll do another video, and today we will do another video on undetermined coefficients in differential equations. It is kind of hard problem, so it is one of those kind of hard ones. So it looks simple, but it's when you start doing all the bunch of algebra that is required, it requires a little work. Um, so so it says y prime plus 4y equal to sine 2x. So that is the problem that is given, right? So now we need to find A and V's, right? Or A, B, and C's, right? The coefficients, right? But step one, okay, so we identify the problem and we know that is not equal to zero, so therefore qualifies to use this method of undetermined coefficient, which means that it's not a homogeneous differential equation. So this is a non-homogeneous differential equations. So therefore we need to use the method of undetermined coefficient to solve it. And we do this by find the complementary solution first, right? So what will be the complementary solution? Complementary solution, the first step, we make this right here equal to zero. So we say that y double prime plus 4y equal zero, right? And then what we do is we treat that as a constant because it has a y in there, right? So now what we do is we treat that as a constant. So we do r squared, right? Because the second derivative plus 4 equals 0, right? So now I subtract 4 on both sides. Subtract 4 on both sides and I get the r squared is equal to that negative 4 to the other side. So therefore, right here, we cannot take the square root of negative 4, right? Right? We cannot do that, right? But what you can do is, it is it's what is called multiply that by, let's say, square root of 4 times the square root of 1, negative 1, right? So this negative 1 is equal to I, is equal is equal to I, right? So the imaginary number of this gets multiplied by the square root of that, and therefore the square the root over here will be r is equal to plus or minus I 2I, right? That will be the roots, right? It's an imaginary number. So therefore, when we have an imaginary number, we know that we're dealing with trigonometric functions, and therefore trigonometric functions are usually, like this. So yc is equal to e to the alpha, right? E to the alpha, right? Cosine of the alpha x to the alpha x cosine, and there is a C1 right here, C1 times cosine of alpha, cosine of x plus C2, and then sine of x, right? But in this case, because technically, this should be alpha plus beta, right? So alpha plus I beta, right? But alpha in this case is equal to 0, right? Alpha in this case is equal to 0, but we have a beta. The beta is the 2 that we found, right? So now what is going to beta goes over here, right? So beta usually goes over here, replacing that argument. So because any number to any e number to the zero power is equal to 1, well, that means that just that one gets distributed inside here, right? So technically that one right here, yc, that is equal to 1 because alpha is 0, right? So alpha is 0. Then the whole thing gets multiplied c1 cosine of x plus okay, but now we replace it, right? Now we replace it with this. So now we replace it with 2, right? 2, 2x plus c2 sine of 2x, right? So that is now you distribute that one inside is c is y of c, which is a complementary solution, is equal to c1 cosine of 2x plus c2 cosine of sine, sorry, sine to sine of c2 sine of 2x, right? Notice that we need to kind of pay attention over here. Notice that we have a one, so we have a case over here. This piece, it look exactly like this one right here. So we need to take that in mind, right? We need to, because this is going to create a copy. I don't have a lot of time to spend right now, but we need to compensate for that repetition, right? So now, so now that we have that, we have the complementary solution, right? Now we need to do the rest. So now we need to find that y of p, y is of p, right? Y particular solution is going to be equal to some number on the right, right? But we have a 2 over here, but we're not gonna worry about the 2. What I will do worry about is the coefficient. Actually, if I wrote it right, actually it's a 3. It's a 3. It's not a okay, but this is just okay. So I'm not gonna worry about the coefficient right now. What I will do is having in the format of a cosine, right? But I will find the argument, right? The argument I'm gonna copy over here. So times 2x plus, right? Plus b sine of 2x. Okay. So now we have a something here, right? We have a something. And why we added 2, we add a cosine over here because we're dealing with trigonometric functions. Trigonometric functions also, sine and cosine kind of repeat each other when you take the derivatives, right? So, so therefore, we need to add that, right? So we need to add that plus plus cosine in there, or we need to add, we had a sine, but we need to add a cosine. Okay, let's get this done, right? So now we find that the y prime, y particular, right? Prime of this, right? Now this is the thing that we need to do before we go any further, right? So remember that we say that we have a copy of the sine 2x in the particular solution, so they cannot be equal, right? Those terms cannot be equal. To make it unequal, what we'll do is we say that yp is equal to, we multiply by x, right? We multiply this guy by x. So we say that yp, right? Yp is equal to a cosine of 2x plus b sine of 2x. Now I need to probably just put that at the top because I need some room. I need some room actually. So I need r equal to plus or minus 2i, and I need yc is equal to c1 cosine of 2x plus c2 sine of 2x. right? So I need those pieces of information at the moment. Okay, so let's get this going. Um, so notice that we edit the x, right? We edit the x, and that is going to help us out. Now, what I will do is take the derivative of this, right? And we say that y prime, y prime, y prime, right? The first derivative, because I have a second derivative, but I cannot go to the second derivative in one shot. I got to do first derivative. Y prime, and remember that we have a product rule over here. We have to deal with that stuff, right? It's a lot. But anyway, so take the derivative of this space inside, right? When I take the derivative of that, it's going to be, I keep my x, right? Take the derivative inside, I get minus a sine 2x, right? Plus, plus, b, plus b, and be careful, right here, right? Taking the derivative of this, right? Taking the derivative of this, I gotta move that to the front, right? So 2ax. Taking the derivative. I am doing the chain rule a bunch of times over here. But okay, so yeah. So so I now I gotta do this, right? So now the derivative of this is going to be that times that plus the derivative times the derivative of that, which is going to be 2b cosine of 2x. That's the first derivative. Now I have the product rule multiplying this whole thing, so therefore I gotta just make a copy of this and and do the power and do the product rule, not the power rule, the product rule. So therefore I do plus, right? Plus derivative of this guy is 1, so I don't have to write it down, right? And then I just make a copy of this, a, which is a cosine 2x plus b sine of 2x. Okay, so that is the first derivative. Now we got to do the second derivative of, and this is when it gets kind of hairy. It gets kind of, it's a little bit of algebra going on, but it's doable. So, okay, so now taking the second derivative, do the same thing, right? So we do y double prime, right? Particular double prime is equal to what? Equal to the second derivative of this, second derivative of that, which is what? Which is the second derivative of that is going to, now that guy is coming up front, it's going to be equal to -4, right? I get a negative already there. A, right? Keep my A. Now the derivative of the sine is cosine 2x, right? Now, same thing. The derivative of this is, okay, so that comes at the front, right? So now the derivative of this is just 4, right? But the derivative of this is negative sign, so it's -4b negative sign of x of 2x. Okay? That is only one part, right? So that's basically the step that we took. Now I got to do the derivative of again. Now this guy becomes my copy, right? Plus the derivative of this, right? Right? Plus the derivative of this times this, which is going to be, it's 1, but not going to write it, but it's 1 over there. The derivative of that is 1. And then made a copy. I made a copy of this. I will make a copy, and that is 2a sine of 2x plus 2b cosine of 2x, right? Plus the derivative of this guy, plus the derivative of the guy. This guy is just hanging over here by itself. I will not ignore that one. I need to take the derivative of that. So plus the derivative of this, right, is equal to what? The derivative of this, and this is equal to what? Is equal to negative 2a sine of 2x, and then plus, right? Plus the derivative of that. Again, you know the front is plus 2b cosine of 2x. Okay, that is the second derivative. That is the second derivative. Now, let's look what we can do here. See, that's the thing. That's why this gets kind of right. So let's see what we have. I know I have an A and I have a B, but I cannot do apples and oranges, right? I have to put my oranges in one basket and my apples in one basket. Okay, I cannot do nothing here, nothing. But over here, you can see that I can do something, right? I got cosine and sine. I get an A, negative, negative, and this, I got similar here, similar pieces. Okay, so let's combine those. So now the second derivative of yp, okay, combine this two. I will need to maybe use a different marker to mark this up, underline that, underline that. You need to be careful when doing these problems, making sure that you do a step by step, right? So this is going to be equal to what? It's going to be equal to x. Matter of fact, you know what? Let me just use the black pen because I don't. Sometimes the camera doesn't capture the red pretty good. So okay, so x, right? Now, if you look at this, I can actually distribute that x inside, right? Let's do it in one shot, right? Let's distribute that inside. So what I can do, I can say that negative 4 ax cosine of 2x minus 4bx sine of 2x, and I put my brackets over there. I mean, you don't have to put the bracket. I like to put the bracket just to help me where I am in the problem. Now, if I combine these two, right, combining this guy and that guy, right, and then I can say plus, right, plus plus negative 4 plus negative 4 for a, right, sine of 2 sine of 2x, right, plus, okay, so I am done with this. I'm done with this, right? Now, adding those two, I get what? I get plus. I get plus 4b cosine of 2x. And this is just a second derivative. This is just a second derivative. Okay, so I put this line over here so it doesn't get, people don't get confused. But this is just part of that, right? This is one whole piece right here, one whole thing. Now, that is the second derivative. It's the second derivative. Now, let me Okay. So let me put this over here. So now I have the second derivative. I have to replace this guy by the whole thing. So it's going to be y going to be the y prime, right? Just bringing that down. So it's going to be minus 4 a x cosine of 2x minus 4 b x sine of 2x, right? Plus, I don't know if I want to do this, but this is put a bracket around, kind of helpful, right? Now we do that one plus minus 4a sine of 2x plus 4b plus 4b plus 4b plus 4b cosine of 2x, right? And this is when things get, right? That is not even, that is just the second derivative, right? Now, what I will do, I will use the board so it is more clear. So I will have to erase this and use this board, continuous. Okay, so now right here, I will put a plus for a plus because I need to add this 4. I need to put a 4 in there, and I will continue with that here. So it's going to be 4. Then what didn't we selected first, right? What we did first, we say that y. Let me write it down right here. Y was equal to a, right? A cosine of 2x plus b sine of 2x, right? But be careful, right? This is what you have to be careful. Notice that we added an x. So we add an x to multiply by x. So we need to do the same thing right here. We need to put that right here. And so let me just do it just like this. So it looked tighter right here. So the plus 4, right? Plus 4. And then right here, I'm going to set a bracket, right? But right here, I need to do 4 and keep that x with a 4, right? That right there, right? That x attached to the 4, right? Now, inside, I have to put a cosine x plus b 2x plus b sine 2x. Okay, now you see where I'm going with this. So now this is my y, right? This is my y, but I need to distribute that inside. Okay, let's write everything it's down again. 4a x cosine of 2x minus 4bx sine of 2x plus negative 4a sine of 2x plus 4b cosine of 2x. Distribute that guy inside right here and get plus what? Plus that is going to be equal to plus a plus a plus 4a x cosine of 2x, right? And then distribute that with that is going to be equal to plus b, right? Plus 4bx sine of 2x. Right. I'm telling you, this is it's a little bit of work, but it's worthy. It's worthy. Okay, so now look at this. If you can see right here, if you can see something, hit this. I want to highlight this and highlight. Okay, so I have a two positives over here, and I have a two negatives over here. Okay, look at that. What is really fun right here is that this stuff can at this point when this making sense, you said, okay, I can cancel this and cancel that. So the thing is reducing down, right? The problem is getting easier and easier. Okay? So that is gone, right? This one cancels. I got I got the same thing, right? 4ax cosine 2x negative 4ax cosine 2x, the same thing over here, and the same thing over here. So this cancel with that, gone. This cancel with this, gone. I am only got to have right now is this. That's it. And notice that this, I didn't put it there, but notice that I am because I am just doing the work right now. But this is equal to the right side, which is sine of 2x. Now that I have this, I can actually say, okay, so 4a sine of 2x plus 4b cosine of x plus 4b cosine of 2x equal to what? Equal to 3 sine of 2x. Okay, so this is what is going on right here. So we have a similar, right? Hey, that's what we're going for. So we're going for something like this. So since we don't have this, right now we got to worry of what we know, right? What we have. So now I can say that 4a sine of 2x equal to 3 sine of 2x. Sine of 2x. Cancel this out, and I get a 4a equals 3 negative divided by negative 4 divided by negative 4, and I get that a is equal to negative 3/4. Okay, so now we making some progress, right? So what about b? Did b even exist? No, right? Because this is just 0, right? So you can put 0 there. Okay? You can put 0, whatever, 0 sine of 2x, but this is 0, right? Multiplying that times 0 is still 0, right? Now, what we can do instead of b, okay, so 4 4b 4b sine of 2x is equal to what? Is equal to 0 times what? Times sine of 2x, right? And again, that cancel, in 4b is equal to 0. So therefore, just doing the math for you, you don't have to do this, but b is equal to 0. Okay. All this work, right? Okay, so now we need to write the solution in the form of yp. So yp, right? Yp, that's what I tried to find, right? Yp, actually yp in the bottom. Yp. Now we found A and we found B, right? So now remember that we have a yp with A cosine x plus B cosine x, right? But also remember that we multiply this guy by x. We need to do the same thing here. Okay, so now what I can do is the following. So I say that yp is equal to what? Equal to x, right? And what is my value of my A? I found it over here. So it's 3/4. So it's negative 3/4, right? And what go with it is cosine of x, cosine of 2x. Sorry, it's 2x. 2x, 2x. So what go with it? Cosine of 2x, right? Plus what? What is the other one that we found? Is 0, right? So plus 0 times sine of 2x. Okay, so now look at this. So now I have a dissolution, right? Almost complete. What I do is multiply the x inside, and I know that this is going to be 0 anyway, so I don't have to even worry about it. So close it out. So basically, y sub p, y sub p, y sub p is equal to what? Is equal to, when I distribute that inside, is equal to what? It's equal to negative 3/4 x cosine of 2x. Huh. A lot of work, isn't it? Now, we say last time, right? And if you follow some of my videos, that when I do differential equations, if I do topics like this, I usually explain it that the general solution is equal to the complementary solution plus the particular solution, right? So we say that y sub g is equal to what? It's equal to y sub c plus y sub p. Okay. So now, do we have them? Yes. I got this guy, my y sub c, then I got this, right? So my general solution is y sub g in general is equal to what? It's equal to c1 cosine of 2x plus c2 sine of 2x plus, right? Or in this case, it's going to be minus 3 4 x cosine of 2x. That's it, guys, for this video. I hope you enjoyed the video. If you did, please give me a like. See you in the next video. Remember, Jesus is good, and we learn over here at the Christian Engineering Academy because Jesus is awesome. And that's it. Thank you for watching. See you in the next video.